Have you ever stood in the middle of a garden, your hands covered in rich, damp soil, and suddenly felt an irresistible desire to multiply the life growing around you? To gaze at a magnificent tree glowing in the sunlight and think, I want another one of you, right here, right now. Deep in the heart of every gardener, every farmer, and every person who has ever fallen in love with the earth lives an ancient, almost primal dream. The dream of growing an orchard for free. We want to expand our backyards, fill our fields with sweet fruit, and pass living heirlooms down to our children without spending a fortune. But as many of us already know, nature does not always reveal her secrets easily. When you try to grow a fruit tree from a simple seed, you enter a serious generational gamble. Because of cross-pollination, that tiny seed is unpredictable. An apple or avocado grown from seed will rarely produce fruit exactly like the parent tree. Then comes the painful test of time. A seedling may need 7 to 10 long years just to mature. Years of watering, waiting, and hoping, only for you to discover that the fruit is bitter and almost impossible to eat. Who can afford to lose an entire decade? We want to taste the sweet reward of our work in this lifetime, in this very decade. That is why we turn to vegetative cloning, a way to avoid the gamble and preserve the exact genetic qualities of our favorite trees. Yet traditional techniques, such as softwood cuttings or standard air layering, can still be unreliable, especially with stubborn woody species. But perhaps not anymore. Today, I want to take you on a deeply personal journey into a method that sounds completely wild, even a little brutal at first. I am talking about cloning fruit trees with metal screws. Yes, you heard me correctly. Metal screws. It sounds like something from a mad scientist's experiment, doesn't it? When I first saw this technique spreading online, the skeptical gardener inside me shouted, "No way! You cannot drive metal screws into a living branch and expect roots to appear." But curiosity is the compass of every true lover of the soil. So I quieted my doubts, rolled up my sleeves, and decided to test this strange method on one of the most famously stubborn trees in my garden, a young, beautiful avocado. What happened during the next 7 weeks completely changed the way I understood plant physiology and taught me a powerful lesson about how life responds to trauma. So, pour yourself a warm cup of tea, settle into a comfortable place, and let us step into the silent, miraculous world of trees. Part 1. The Call of the Soil, a gamble on an avocado branch. To truly understand this journey, we have to begin with the branch. I chose a young, healthy avocado tree growing in my orchard. Among horticulturists, avocados are famous for being extremely reluctant to produce roots. While figs and lemons seem ready to send out roots the moment they sense moisture nearby, the avocado behaves like a fortress of stubbornness, fiercely protecting its vascular system. If I could make this screw method succeed on an avocado, I believed it could work on almost anything. I stood beside the tree, studying a branch that was roughly 1 year old. Not too soft and green, but not too old and thick either. Choosing the right branch is one of the most important first steps. If the shoot is too tender and succulent, it may bend, wither, or rot beneath the weight of the setup. But if the branch is old, dark, and covered in thick bark, its active growth has already slowed, and it may take an eternity to respond. What you need is the perfect middle ground, a branch that is sturdy enough to support the process, still actively growing, and visibly full of life. I started by removing the side shoots, small leaves, and tiny twigs along a 5-centimeter section of the branch. I wanted a clean working area. As my clippers cut away those minor leaves, I felt that familiar sting of guilt. Every cut creates a wound. Every snip interrupts the tree's daily effort to reach toward the sun. But as gardeners, we must recognize that thoughtful intervention is sometimes necessary to awaken a plant's hidden potential. I marked a 2-inch section, about 5 centimeters, directly beneath a leaf node. This small area would become the center of the entire experiment. Have you ever wondered why the leaf node matters so much? In botanical terms, the node is where the real magic begins. It is a biological crossroads filled with dormant buds and highly active cells, all waiting for the right signal to change their destiny. As I held the metal screws in one hand and the screwdriver in the other, my heart began to race. I asked myself, am I about to damage this beautiful tree, or am I preparing to guide it toward an extraordinary rebirth? To understand why this method works, and why it is not simply an act of senseless harm, we need to look inside the tree's microscopic highways. Part 2. The hidden highways, understanding the vascular system. Imagine a tree not as one solid piece of wood, but as a complex and carefully organized city made of microscopic pipes. These tiny channels run continuously, from the deepest root tips buried in dark soil to the highest leaves moving gently in the sky. This transportation system is divided into two main highways that run side by side. At the center of the branch lies the xylem. The xylem is the tree's upward highway. Its single, enormous responsibility is to carry water and dissolved minerals from the roots into the canopy, keeping the leaves hydrated and firm enough to perform photosynthesis. The xylem is formed from tough, lignified cells that also give the branch its physical strength and structural support. Just outside the xylem, directly beneath the bark's protective surface, lies the phloem. The phloem is the tree's downward highway. After the leaves capture sunlight and produce sugars, starches, and organic compounds, the phloem carries this essential food downward to nourish the trunk, the lower branches, and the entire root system. Perfectly positioned between these two major highways is a microscopic, single-cell layer known as the cambium. The cambium is the plant's stem cell zone. Its cells are undifferentiated, which means they do not yet have a permanent identity. When they divide inward, they become xylem, or wood. When they divide outward, they become phloem, or bark. The cambium is the engine behind radial growth, the living layer that allows a tree to become wider year after year. Now consider traditional air layering. In the standard method, a complete ring of bark is removed from the branch, and the cambium is scraped away. This fully interrupts the downward movement of nutrients through the phloem. Because the central xylem remains intact, water can still travel upward, preventing the leaves above from dying. But the nutrients moving downward reach a dead end at the top of the cut, forcing the plant to produce roots in that area as it searches for a new source of water. So what happens with our new screw method? Instead of removing a large ring of bark and creating a highly stressful open wound, we insert 8 steel screws at different points around the branch. Think carefully about what this does. Each screw passes through the bark, penetrates the phloem, and reaches deep into the xylem. In doing so, it creates several intense but highly localized points of vascular disruption. The phloem is blocked in specific areas, while most of the bark remains completely intact. As a result, the branch experiences far less systemic shock than it would from one large, exposed wound. It becomes an elegant and localized interruption. The branch continues functioning almost normally and maintains its strength, while the microscopic wounds surrounding each screw trigger an emergency response in those precise locations. And this leads us into the remarkable chemistry of survival. Part 3. The callus of survival. Turning trauma into roots. How does a plant heal itself? It does so through a process that is deeply beautiful, both biologically and philosophically. When plant tissue is injured, the cells around the wound immediately begin dividing at a rapid rate. They create a soft, irregular, whitish-yellow mass of tissue known as callus. Callus is essentially a blank slate. It is a cluster of totipotent stem cells carrying the genetic ability to develop into an entirely new duplicate plant. But callus does not develop by itself. It needs a hormonal director, and that director is auxin. Auxin is the master hormone of plant development. It is produced in active growing tips and young leaves, then flows steadily downward through the phloem. But when it encounters the physical barriers created by the screws, that downward movement becomes blocked. Auxin, together with vital carbohydrates and starches, begins building up in high concentrations around the screw holes. This hormonal bottleneck sends an urgent and unmistakable message to the undifferentiated cambium cells. We have been cut off. We must survive. Build roots. Under the influence of these high auxin concentrations, the callus tissue around the screws begins to differentiate. Its cells organize themselves, establish new vascular pathways, and transform into adventitious root initials. These are completely new roots, created through trauma and emerging directly from the wounded areas. To me, this is one of the most beautiful metaphors found anywhere in nature. The tree does not see the metal screw only as a weapon of destruction. It sees the wound as a chance to adapt. It takes the pain of the puncture, redirects its internal reserves of auxin and starch toward the damaged area, and uses that very trauma to create an entirely new system of survival. Is that not a powerful lesson for our own lives? When we are pierced by the unexpected screws of life, when our normal pathways are interrupted and we feel wounded, our first instinct is often to believe that we are broken. But perhaps, like the tree, we can learn to redirect our deepest energy toward the wound. Perhaps we can allow our own callus to develop, gather our strength, and begin growing new roots that may one day anchor us even more deeply than before. But for this healing process to succeed, we must become careful and protective stewards. We cannot simply drive rusty screws into a branch and walk away. The wound must be prepared with care, sanitation, and natural medicine. Part 4. The preparation. Aloe vera and cinnamon. Nature's disinfectants. Before beginning the physical procedure, we first need to create a clean, sterile working environment. But just as a surgeon prepares carefully for a delicate operation, a gardener must make sanitation a priority to prevent the spread of disease, fungi, and harmful pathogens. I started by thoroughly sterilizing my screwdriver and all 8 steel screws with concentrated rubbing alcohol. Then I used a beautiful, completely natural technique that I had learned through years of working closely with the soil. I picked a fresh, thick aloe vera leaf from my garden and sliced it open, revealing the clear, glistening gel inside. Before placing the screws into the branch, I pushed each of the 8 steel screws directly into that gel. Why aloe vera? Aloe vera is one of the plant kingdom's most remarkable gifts. It contains natural antiseptic, antibacterial, and antifungal compounds that help protect an open wound from aggressive pathogens. On a mechanical level, its thick and slippery gel also works as a natural lubricant. It coats the threads of each screw, helping them move more smoothly through the branch's tough, fibrous layers, while causing as little tearing as possible. From the very first moment of contact, the gel helps keep the entry point clean, moist, and protected. With the screws coated in aloe gel, I picked up my screwdriver and began inserting them into the marked 5 cm section of the avocado branch. I placed them at different points, spacing them as evenly as possible around the branch's circumference. As the metal threads entered the bark, I could feel the resistance of the living wood. I turned the screwdriver slowly, applying firm but controlled pressure. I did not want to drive the screws in too quickly and split the branch, but I also did not want them to remain too shallow. I continued until each screw head rested securely against the bark. 8 screws, 8 concentrated points of physical disruption. Once every screw was firmly positioned, I took a small handful of ground cinnamon and sprinkled it generously across the entire area, coating the screw heads and the bark surrounding them. Anyone who has followed my channel for a while already knows that cinnamon is one of my favorite garden essentials. It is a powerful natural antifungal agent. When a tree is wounded, the exposed tissue beneath its bark becomes especially vulnerable to mold and rot, particularly inside the warm and humid conditions of an air layer. A light covering of cinnamon creates a protective shield, helping repel fungal spores while filling the garden air with its warm, spicy fragrance. Now that the branch had been wounded, treated with aloe, and protected with cinnamon, it was time to create the cradle where those new roots could begin to grow. Part 5. Building the cradle. The cup, the soil, and the moon. Every newborn root needs a dark, nurturing, and highly stable environment in which to develop. To create that space, I used a simple and inexpensive disposable plastic cup. I made a vertical cut down one side of the cup, continuing all the way toward the center of its base. I also added several small drainage slits. Then I carefully opened the cup around the branch, positioning it so the wounded section covered with screws rested directly in the middle. To keep the cup secure, I tightened a black zip tie around its center, holding it firmly in place so it could not slide or shift. Next came the growing medium. I selected a high-quality universal potting mix that drained extremely well, held plenty of moisture, and resisted compaction. A mixture containing equal parts peat moss and coarse perlite works perfectly for this purpose. Its soft, sponge-like structure allows the fragile new hair roots to breathe while remaining continuously hydrated. I slowly filled the cup with the growing medium, pressing it gently into place with my fingers so that no empty air pockets remained around the screws. The damp soil needed to make firm, close contact with the wounded bark. Once the cup was completely filled, I watered it thoroughly for the first time, but the setup was not finished. To imitate the dark, protective conditions beneath the soil, all sunlight needed to be blocked. I took a sheet of black plastic cut from a clean garbage bag and wrapped it completely around the cup. Then I sealed both ends tightly with zip ties. This black plastic covering performs two essential functions. First, it keeps the rooting chamber in complete darkness, providing a strong physiological signal that encourages root development. Second, it absorbs heat from the sun, creating a warm and humid microclimate inside the cup that greatly accelerates cellular division. Now let me share a small secret from traditional farming. Many experienced, old-school gardeners prefer to carry out this entire process during the waning, descending moon. According to agricultural folklore, as the moon moves downward and its light gradually fades, the sap and energy of the plant are naturally drawn toward the root zone. Modern science may debate exactly how this process works, but I have always felt that aligning garden tasks with the natural rhythms of the sky brings us closer to a deeper and more mindful way of farming. From this point forward, maintenance was wonderfully simple. Every 10 days, I gently opened the top of the black plastic covering and added a small amount of water to keep the soil consistently moist. But while the weeks passed quietly, there was one important and highly debated question that still needed to be addressed. Part 6. The Wisdom of Arborists. Temporary Metal versus Permanent Harm. If you speak with professional arborists or forestry specialists, they will give you one very serious and unmistakable warning. Never drill, tap, or hammer metal into a tree. And they are absolutely right. When a nail or screw is permanently driven into a mature tree to hold a birdhouse, hammock, or clothesline, it creates a lasting entry point for decay, pests, and wood-boring insects. The tree must then spend enormous amounts of energy activating a physiological defense system known as CODIT, compartmentalization of decay in trees. It seals off the wounded area to protect the rest of its structure, but over time, this can severely drain the tree's energy reserves, especially if it is already stressed or diseased. Leaving metal permanently buried inside a tree trunk also creates a hidden and extremely dangerous hazard for future arborists, who may eventually need to trim or cut that tree with a chainsaw. Striking the concealed metal could cause catastrophic blade failure. So how can we reconcile this professional warning with the screw cloning method we are using? The key word is temporary. Unlike a permanent nail hammered into a mature backyard oak, these screws are being used as a temporary physiological tool. They are inserted into one specific young branch that will be completely separated from the mother tree after only a few weeks. The parent tree experiences nothing more than a small, localized disruption on a single branch, something it can easily compartmentalize without compromising its overall vitality. After 7 weeks, once roots have successfully developed inside the cup, the branch is cut completely away from the mother tree. The screws can then be carefully removed or safely left within the harvested root ball of the newly independent tree. Either way, the mother tree remains entirely free of metal. This is a controlled and mindful technique that respects the biology of the parent plant while using its natural healing response to create new life. It is not vandalism. It is a cooperative evolutionary dance between human ingenuity and the remarkable resilience of plants. And now, after 7 long weeks of waiting, watering, and trusting the silent work of the earth, the moment of truth has finally arrived. Part 7. The Revelation. Unboxing the Masterpiece. This is the moment every gardener waits for, the moment when something invisible finally becomes visible. I cut through the outer zip ties and slowly, carefully peeled away the black plastic covering. As it fell open, I could not help but gasp. Through the clear wall of the disposable cup, I saw something breathtaking. A thick mass of pure white, incredibly healthy roots wrapping completely around the soil. They were not thin, weak, or fragile. They were strong, vibrant, and overflowing with life. They had emerged directly from the localized wounds made by those 8 steel screws, spreading eagerly through the peat and perlite. I picked up my pruning shears, positioned them just below the cup, and with one clean, decisive cut, separated the branch from the mother tree. Holding the newly born avocado tree in my hands, I could feel the weight of this successful clone. I carried it to my workbench with an overwhelming sense of triumph. Using my shears, I slowly and gently removed the plastic cup from around the root ball. I took great care not to disturb the soil or damage the delicate new hair roots. One of the most important rules when transplanting a newly rooted clone is to keep the rooting medium completely intact. Do not wash away the peat, and do not try to comb apart the roots. Those tiny root tips are extremely fragile, and disturbing them at this stage can cause severe transplant shock. I prepared a large 11-liter pot filled with the same rich, well-draining potting mix. I created a deep opening in the center, gently lowered the rooted clone into place, and filled the empty spaces around it with more soil. Then I pressed the surface lightly with my hands to hold the tree firmly in position. After that, I watered it thoroughly and watched the excess water drain freely from the bottom of the pot. Now came another highly important stage, the adaptation period. For its entire life, this branch had received water, nourishment, and protection from its large mother tree. But today, it was suddenly independent. Its root system was still young and developing, and it was not yet capable of handling the intense loss of moisture caused by direct sunlight. To help it adjust, I placed the newly potted tree in deep, protected shade for the first 7 to 10 days. I kept the soil consistently moist but never waterlogged. This gave the roots enough time to adapt, expand into their new environment, and prepare for a lifetime of independent growth. And just like that, with a simple screw from the hardware store and a little faith in the garden, a brand new fruit tree was born. As I stand here looking at this young, independent avocado tree, I am reminded of another extraordinary technique practiced by professional bonsai artists, the Ebihara method. When propagating a young tree, artists sometimes place the flat base of its trunk directly against a wooden board or plastic disc and secure it with a screw before planting it in the ground. It sounds harsh, does it not? But the flat board serves as a physical barrier. Because the roots cannot grow vertically downward, they are forced to spread outward in every direction, creating a flat, radial pattern across the entire surface of the board. The result is a broad, magnificent, and exceptionally stable root base known as nabari. This radial root system does more than give the tree the appearance of ancient and powerful maturity. It anchors the tree so firmly to the earth that wind, storms, and erosion cannot easily bring it down. As I think about the Ebihara board and the 8 screws that brought this avocado branch into a new life, I realize that the garden is always holding up a mirror to our own human journey. We live in a world that moves quickly, feels chaotic, and can often be deeply disruptive. Unexpected wounds, sudden changes, and moments of overwhelming stress strike us again and again. Yet the wisdom of trees teaches us that stability does not come from avoiding trauma, it comes from learning how to ground ourselves through it. Like a tree shaped by the Ebihara method, sometimes we need to be screwed to the board of reality. We may need to stop reaching downward in fear and instead begin spreading our roots outward, toward our communities, our loved ones, and the simple, enduring rhythms of the earth. We must learn to turn our wounds into pathways for new growth and create a spiritual nabari so balanced and deeply anchored that we can remain standing through every storm life sends our way. Thank you so much for walking this beautiful journey of discovery with me today on Earthly Delights. Before you leave, I have a question for you. Which country are you watching from today, and which stubborn fruit tree in your garden will you try this screw method on? Tell me in the comments below. I read every one of them, and I truly love hearing about your own adventures in the garden. If this video inspired you to see your trees, and perhaps your own challenges, from a slightly different perspective, please give it a like, share it with another gardener, and subscribe so you will not miss our next journey into the wonders hidden within the soil. Keep growing, keep healing, and keep grounding yourselves. I am sending a huge, warm hug from my garden to yours. Goodbye, and I will see you in the next one.